video, we are going to see a problem on induced shear stress in a metal rod. For that, here we have a question. A 12 diameter MS bar made up of mild steel, when tested for single shear, carries a load of 8.16 kilonewton. Determine induced shear stress. So this is the problem. Let us try to write the data for this. A 12 diameter MS bar, so diameter is given, when tested for single shear carries a load of 8.16 kilonewton. So load is denoted by P, it is 8.16 kilonewton. So I'll convert it. It is 8.16 into 10 raised to 3 Newton. Determine induced shear stress. Here we have to find out the value of shear stress tau. Now for this, first I'll draw the diagram and explain what is the meaning of single shear. Now here we have two plates between the two plates we are having a mild steel bar. Now the diameter of the mild steel bar is 12 so in both the plates there would be a hole of 12 and on one plate, that is the upper plate, if we apply a force towards right, on the bottom or lower plate if we apply a force towards left. Now because of these two opposite forces, their magnitude is same. What can happen is that this mild steel bar, which is circular in cross section since the diameter is given, it will break at this junction at the plate, and when it breaks it will look like this. It will break into two halves, and this area which we are getting, this is called as the shearing area. And this, since here we are getting two pair of area, like one area would be here, other would be here, so here we are getting, actually it is two area, means this is one pair of area, and since here we have one pair of area, this case it is called as single shear. And now we have to calculate the induced shear stress, that is when we have been applying this load, because of that how much is the shear stress which is induced in the mild steel bar, that we have to calculate. So let us try to get the solution for this problem. Now as we can see in this problem, the shearing area is a circular cross section, so I'll draw this. Here we have this diameter as 12 and this is the shearing area, and it is single shear because we get one pair of area. So first I'll write down, since shearing area is given by A is equal to, here we are getting cross section area, so pi by 4 into d square diameter is 12, pi by 4 into 12 square, and my answer is 113.09 mm square. After getting this shearing area, as the question is of stress, stress is load upon area. So I'll write down after this, since shear stress is given by tau is equal to load upon area, so therefore tau is equal to, load is given in the problem as 8.16 kilonewton, so it is 8.16 into 10 raised to 3 Newton divided by area, which is 113.09. So from this I'll be getting the value of shear stress, which comes out to be 72.15 Newton per mm square. So here I can say that therefore induced shear stress in ms bar, that is tau, is equal to 72.15 Newton per mm square. So here in this problem, the question was to calculate how much is the shear stress induced in this mild steel bar when it is subjected to shear force, and that stress value we have calculated, it comes out to be 72.15 Newton per mm square, and with this we complete the problem.